Hey everyone, this is notes number 11, converting radians to degrees. So if you finish notes number 10, you'll notice that this sounds very similar to what we did in notes number 10, right? In the previous notes, we did converting degrees to radians. So now, can we convert back from radians to degrees, right? So first off, before I show you how to actually do it, the purpose of it is to know how to be flexible with angles, because sometimes they'll give it to you in degrees, sometimes they'll give it to you in radians, and sometimes you want radians and sometimes you want degrees. So it kind of just depends, right, on every problem. So before we get back into that trig realm where we're learning about sine, cosine, and tangent and such, we need to make sure that whatever angle they give us, we can easily modify it if needed. Okay? So your goal, write down this FLT. Today is we're going to start off with radians and we want to convert that to degrees. So remember, when you're converting, okay, you're not changing the value of it. They're both equivalent. Okay, so remember, 24 inches and 2 feet are written very differently, but they're actually equal because 24 inches is actually 2 feet here, okay? So it's the same idea whether you write in radians or degrees. You'll still end up with the same value, okay? Okay, so just some things to think about. You're either using your iPhone here, right, or a scientific calculator, or I just realized some of you are actually using graphing calculators, which is cool too, okay? It doesn't matter which one you guys use, but what I do want to point out for today's lesson is you want to be able to find your pi button, okay? So I want you to go ahead and pause this video, look at whatever calculator you're using, and see if you can find the pi button, okay? Go ahead and press play whenever you're ready. So if you were using the iPhone's calculator, the pi button is actually right here, just to make sure that you guys know where everything is, okay? If you were using the scientific calculator, this is probably the most common one, but don't worry if you have a different version because it's all there. Pi is actually a button right here, okay? So you kind of have to look around. If you're using the graphing calculator, it's right here in blue. So what you would have to do is you would have to press the blue button and then this button afterwards to access it, okay? Now, if you're looking at your calculator that's not listed here and you can't find it, just text me. Send me a picture and I'll let you know where it is, okay? Cool. So here we go. There are two types of examples. Very easy to do, both very easy to do. And I'm going to show you two different ways of doing it. And I'll tell you the pros and cons of each method there, okay? So we'll write this down once. Convert your angle from radians to degrees. Okay? Press play when you're ready. All right. So you're going to start off with some type of radian. So the first most common example is when you're dealing with something that has pi in it, okay? So for instance, let's say we did pi over 3, okay? So here's the first method, okay? Your t-chart. This is what we're used to, okay? We're going to draw a t chart to separate the numerators from the denominators, okay? We're going to do the exact same thing, okay? So if you want to get rid of the pi radian, now you know what? Let me fix this real quick. Now, sometimes you'll see the problem like this, but really what it has there is an invisible radians there. And sometimes it's not written, sometimes it is, but just know that it can play either way, okay? So it doesn't matter if it's there or not, but I'm just going to put it here for this example. we'll go ahead and do our t-chart here. Okay, and you can just decide to multiply by a fraction if that's easier. Okay, so what you start with is what you want to have down here. Okay, so I'll use a darker color so you guys can see. So we want radians down here, and we want to convert to degrees up there. Okay, so what do we know about this conversion, right? Fill in the blanks there, press play when you're ready. We know that 180 degrees makes 1 pi radian. So remember that conversion, okay? 1 pi radian is the same thing as 180 degrees. All right? Okay, so when you have this set up, radians goes away, and so does the pi. Look at that. We have a pi on top and a pi at the bottom here, okay? So what you end up getting here is we're just left with 180 degrees at the top divided by just 3 because everything else went away. 180 degrees divided by 3 is 60 degrees. So pi over 3 and 60 degrees, although written very differently, they're both equal. They're both equivalent, okay? Very easy to do, all right? Now, I'm going to show you another way. Here's the second method here. And I'll tell you guys now, this second method is a lot faster, but the downside to it is that it doesn't always work. And I'll show you when it doesn't work, okay? So if we start off with the same thing, pi over 3 radians, okay? Here's what you do. Knowing that 1 pi radian is equal to 180 degrees, what you can do here is you can replace that highlight for 180 degrees. You're substituting or plugging in 180 degrees. And from that, you get 60 degrees. Okay? Now, the first method, although it takes a little bit longer, it always works. That's the positive to it, okay? It always works. The second method is a lot faster, but it doesn't always work for every situation. Okay? So, first I'm going to have you guys try this, all right? Here's part B. Okay? And I want you to try it in both methods here, just for this one example, all right? So I'm going to give you, let's do 4 pi over 3. Go ahead and try this one on your own. Actually, you know what? That's a bad one. Let me get rid of that. Let's do pi over 4. Okay, try that on your own using both methods and press play when you're ready, okay? Okay, first method, t-chart. 1 pi radian is equivalent to 180 degrees. All right, pi's will cancel out. The radians will cancel out as well, even though I didn't write it there, okay? But you're just left with 180 degrees divided by 4, which is 45 degrees. 45 degrees is the same thing as pi over 4. Okay? Okay, the second method is to just substitute, replace the pi with the 180, which gives you 45 degrees, okay? Now, at this point, I think almost all of you are leaning towards the second method, which you should because it's faster, right? In math, you're always trying to find the most efficient way. That's kind of like the theme, right, of all of the math problems. You're trying to find the most efficient way, and you should. So let's keep going. Here's one more. Part C. Let's do 5 pi over 6. Okay, go ahead and try that one. And I'll let you go ahead and use whichever method you like, but make sure that you label it. If you use the first method, write first method, okay? If you use the second method, write second method. Press play when you're ready. Okay, so here, the second method I think is a lot easier. All I do is I replace the pi with a 180. So this is the same thing as 5 over 6 times 180 degrees. So I replaced the pi with the 180. Okay. I substituted, I plugged in, I replaced the pi with 180 because 1 pi radian is equal or equivalent to 180 degrees, okay? Once you multiply this one out here, you can multiply this out using your calculator, but if you want to be a little bit quicker with it, here's the strategy. I know that 6 goes into 180 in a very clean manner. 180 divided by 6 is actually 30. And then 5 times 30 is 150 degrees. Now, some of you might have multiplied across 5 times 180. What the heck is that? It's 900. And then divided by 6 is 150. You could have done that too. Personally, I like to make numbers smaller first because when you make numbers larger, it's harder to deal with, okay? But whichever way you guys decide, you end up with the same answer here, okay? So know that 5 pi over 6 and 150 are equivalent or equal, okay? Written very differently, but they're equal in value, all right? Okay, let's do one more, and then I'll show you the last example here. Suppose you guys had 7 pi over 4. Okay, go ahead and convert that to degrees. Press play when you're ready. Okay, so just to play it fair, even though the second method is more efficient, I'm going to go ahead and show you the t-chart here. Okay, that means pi would have to go down below, 180 degrees would have to go up top. That causes the pi's to go away. And if we multiply this one out, I think the 4, let me write this out so you guys can see it. 7 times 180 divided by 4. I'm going to try to divide the 4 first into 180. What is that? 90, 45. Okay, and 7 times 45 is, oh gosh, 315? Let me double check. 315. 315. Now, don't just write 315. It's 315 degrees. Units are very important, okay? Remember, 315 and 7 pi over 4, 315 degrees, and 7 pi over 4 are equivalent. Don't forget that. Okay, so just to recap, if we're revisiting our quadrants, if you guys remember the 4 quadrants, quadrants 1, 2, 3, and 4. Okay, pi over 3 is in which quadrant, right? So we know that pi over 3 is the same thing as 60 degrees. And I know 60 degrees is somewhere in between 0 and 90 because we go counterclockwise. So that means that in part A, this is really quadrant 1. Okay. Pi over 4 turned out to be 45 degrees. And 45 is also in quadrant 1. All right. 5 pi over 6. Go ahead and do part C, 5 pi over 6, and part D, 7 pi over 4. Press play whenever you're ready. Let me know what quadrants these angles lie in, okay? Okay, so we know that 5 pi over 6 is equivalent to 150 degrees, and 150 degrees is somewhere in here between 90 and 180. So we know that that's quadrant 2. So that means 5 pi over 6 is somewhere in quadrant 2. Okay? In part D, 7 pi over 4 actually came out to 315 degrees, which is somewhere in between 270 and 360. So you're somewhere in quadrant 4. Okay, so that means 7 pi over 4 comes out in quadrant 4. Okay? All right, here's the last type of example. So at the beginning, I told you that there were two methods. One took longer, but it always works. The second one is faster, but it doesn't always work, right? So you're more than welcome to use any method, but it depends on what type of problem you guys get. So here's something that you guys might see. Here's example 2. Same directions, okay? Okay. So what if I gave you 6 radians? Okay. Go ahead and write that down. Now, what's weird about that? Right? If you take a look at the last few examples that we did, how is this one different from all the previous examples? Press play when you're ready. But really do think about this one. How is this example 2 different from all the previous ones? Okay? Okay, probably easy to tell. But normally we have a pi, but this one has no pi. So I'm just going to write that down there. We have no pi here. Okay? So if there's no pi, we can't replace a pi with 180, which is why the second method does not work. If there is no pi present, we can't substitute, right? So we have to do it. We have to revert back to the first method. So here's what we do. T-chart. Here we go. We put radians down here, and we want degrees up here. Same as always. Go ahead and fill in the blank there, okay? What's the conversion? Press play when you're ready. So we know that 180 degrees makes 1 pi radian. That will never change, you guys, okay? Okay, so from here, what cancels out? Notice how radians and radians cancels out, but you still got that pi at the bottom. So how do you handle that, right? This is something that you can't really do by hand, okay? So on top, what we have here is 6 times 180 degrees divided by 1 pi, but I'm not going to put the 1 because it's invisible, right? So this is where you have to use your calculator, okay? So first, 6 times 180, let me go ahead and type that in, is 1,080 degrees divided by pi, okay? So here's what you do. Here, you have to divide by literally pi, okay? So find your pi button. If you did it right, you should get 343.7746 and so forth. Okay? I think on Delta Math, they ask you to round to the nearest 10th. So this right here is the 10th place. So you look at the digit after, and since it's 5 or larger, you know this is going to be 343.8 degrees. Okay? Which kind of makes sense because remember, a full circle is 360 degrees. So remember, a full circle is 360 degrees, which was the same thing as 2 pi. And 2 pi is about 6.28 something, which is kind of what we have. So it's a little bit shy. okay? Here's some common mistakes that I see people do, okay? They try to replace the pi with 180 here, okay? If you don't have a pi to begin with, there should be no substitutions involved. So this pi on your calculator, when you press pi, you're really doing 1080 divided by 3.141592653 and so forth. That's really what you're doing on your calculator, okay? Pi is not 180. 1 pi radian is equal to 180 degrees. So this is where it kind of gets a little bit weird, right? So let me write this carefully. 1 pi radians is equal to 180 degrees. But if you just have pi alone, by itself, this is really just 3.14 approximately. Okay? Don't press 3.14 because if you round it, you could throw off your answer. So you want to find that pi button because it gives you extra digits. Okay? It gives you all of these extra digits right here that you might not remember. Okay? So let's try a few, okay? Here's part B. What would happen if I gave you 4 radians? Go ahead and try that on your own. Press play when you're ready, okay? Okay, so here we go. No pi, so we can't use the second method here. No substitutions. If I have radians at the top, I want radians at the bottom. Okay, and I want to convert it to degrees. I know that 180 degrees is the same thing as 1 pi radian. This causes my radians to cancel out, and I'm left with just 4 times 180 degrees over 1 pi, which is the same thing as 720 degrees divided by pi. Okay, so 720 divided by 3.141592653, right? Or instead of remembering all of those digits, you could just say 720 divided by, and then whichever calculator you're using, find your pi button. And if you did it right, you should get 229.1831, so forth. So if I round that to the nearest tenth, it'll be 229. Again, the 10th place is right here. So I look at the digit after. Since it's 5 or larger, that 1 will bump up to a 2. And that's 229.2 degrees. Okay? Let's try another one. Here's part C. Let's do 3.2 radians. Okay, try that on your own. Press play when you're ready. Okay, so again, there's no pi here, so we can't use the second method. We cannot plug in. So you start with radians, you're going to end up with radians. Okay, and you want to end up with degrees. Okay, I know that 180 degrees is the same thing as 1 pi radian. This is going to allow radians to cancel out in units, and you're left with degrees. So we have 3.2 times 180 degrees all over 1 pi, or just pi, right? Let me get rid of that 1 there. Okay, so this one here, since it's dealing with decimals, I would encourage you to just type it out. 3.2 times 180. And when you're typing it on your calculator, there's really no need to type the degree symbol, so just keep that in mind, okay? 3.2 times 180 divided by that pi button. And if you did it right, you should get 183.3464, so forth. And if we round it to the nearest 10th, here's the 10th place. So I look at the digit after. Since it's 4, it's not 5 or larger. That 3 will stay as a 3. And that's in degrees. Don't forget your units there, okay? So 183.3 degrees approximately is equivalent to 3.2 radians. 229.2 degrees is equivalent to 4 radians, and so forth, right? 343.8 degrees is equivalent to 6 radians. All right. Here's the last one. Part D. So suppose you had a negative 1.5 radians. Go ahead and try that. Okay. So this one's weird because you end up with something negative, right? First off, what the heck does that negative even mean? Can you have a negative angle, right? More on that later in a future lesson, okay? We'll talk about that, and I will explain it to you logically on what that negative represents. But for now, just treat it as a value, okay? So we start with radians, so we want radians down below. And we want to end up with degrees, so we put on top. I know that 180 degrees is equivalent to 1 pi radian. That allows radians to reduce out. And we're left with negative 1.5 times 180 degrees all over pi. Okay? Now, I typed this out. I could type out the negative, but I know that a negative times a positive is just a negative there, so I'm just going to put that there. 1.5 times 180 divided by the pi will give me negative 85.943 and so on. If I round this to the nearest tenth, I look at the 10th place and then I look at the digit after. Since 4 is not 5 or larger, this will remain as negative 85.9 degrees. Okay? So negative 85.9 degrees is equivalent, approximately, equivalent to negative 1.5 radians. Now, what the heck is a negative angle, right? Like, isn't that illegal, right? We'll talk about that in a future lesson, but for now, just learn how to convert from radians to degrees in this lesson, okay? That's pretty much it. If you have any questions, do let me know. Text me through Remind, okay?